It looked like a creature from a fever dream. Spindly legs, razor-sharp spines, and a face no one could even recognize. For decades, scientists couldn't tell which way it was facing, or even if it was real. This is Hallucigenia, the prehistoric animal so strange, so alien. Some paleontologists thought it was a mistake, but it wasn't. It lived. Born in the Cambrian seas over 500 million years ago, Hallucigenia is the fossil that flipped evolutionary science upside down, literally. It was originally reconstructed walking on its own spikes. It had no eyes, no brain, and maybe no front or back. So how did something this bizarre even evolve? Why did it survive in an ocean full of predators? And what secrets does this ancient worm hold about the origins of life itself? Imagine diving into the ocean 500 million years ago. Not into blue tropical waters, but a shadowy alien sea teeming with creatures that looked like they came from another planet. Among the wriggling arthropods and spike-covered predators, something even stranger drifted near the seafloor. Something so outlandish, scientists would spend over a century trying to make sense of it. That creature was Hallucigenia. And yes, that's its actual name. It lived during the Cambrian Explosion, around 508 million years ago, a chaotic evolutionary arms race when nature rapidly churned out experimental body plans at a breakneck pace. Limbs, eyes, spines, teeth, everything was on the table. Evolution was throwing spaghetti at the wall to see what would stick. Hallucigenia, it seems, was one of the weirdest experiments of all. First discovered in 1911 by Charles Doolittle Walcott in the Burgess Shale of the Canadian Rockies, the fossil was initially misclassified as part of a segmented worm species named Canadia sparsa, but buried in the fine sediment was a creature no one had ever imagined. About the size of a human thumb, with long noodle-like legs, spiny protrusions like toothpicks, and a soft, tubular body. In 1977, British paleontologist Simon Conway Morris re-examined the fossil and realized it was a new genus entirely. The name he gave it? Hallucigenia, inspired by how dreamlike or nightmarish the animal appeared. But as bizarre as its appearance was, the real mystery was just beginning. Because Conway Morris and the rest of the scientific community got it completely wrong. The original reconstruction of Hallucigenia looks like a joke someone might draw on a napkin during a fever dream. It was portrayed with 7 pairs of needle-thin spines used as legs and a row of soft, wiggly tentacles sticking out of its back like party streamers. In this version, Hallucigenia awkwardly shuffled across the ocean floor atop its own spikes, an impractical, almost self-sabotaging method of locomotion. Conway Morris also believed that the animal's head was a featureless, globular nub and the tail curled forward like a scorpion's. Some of the tentacles, he speculated, might have even functioned as individual mouths, each grabbing bits of food and funneling them into a central digestive tract. To the modern eye, it looked more like a rejected alien design than a real prehistoric creature. But the fossil record didn't lie, even if scientists misread it. For over a decade, this upside-down version of Hallucigenia was accepted, or at least tolerated, in paleontology circles. It was just that weird. Some researchers even proposed that it wasn't an organism at all, but rather a dismembered part of a larger animal. Then, in 1991, everything changed. A new fossil, a close relative of Hallucigenia called Microdictyon, was discovered in China. This worm-like creature had similar soft legs, but they clearly touched the ground. It wasn't walking on spikes. 1 year later, researchers returned to the original Hallucigenia fossil and discovered what had previously been missed: a second row of legs, buried beneath the fossil matrix. Hallucigenia hadn't been walking on its spines at all. It had simply been drawn upside down for years. The tentacles were legs, complete with clawed tips. The spines were on its back, likely used for defense against predators like Anomalocaris, the terror of the Cambrian seas. Paleontology had made a massive error, and the scientific community had to eat some humble pie. But the truth made Hallucigenia even more fascinating, because this wasn't just a misunderstood worm. It was a creature with a body plan almost no modern animal has. Once the scientific world flipped Hallucigenia right side up, a clearer but still deeply strange picture began to emerge. This creature was tiny, just 1 to 5 centimeters long, about the length of your thumb. Its soft, worm-like body was supported by up to 10 pairs of stumpy, tubular legs, each ending in tiny claws or hooks. The back legs had double claws, possibly for gripping the sea floor, while the front limbs were more slender and flexible, likely used to guide food into its mouth. Speaking of mouths, Hallucigenia's was a nightmare in itself. In 2015, scientists finally revealed what its head looked like, and it didn't disappoint. It had an elongated head with 2 simple eyes, no brain, and a circular, tooth-lined mouth. Surrounding the mouth was a ring of hard, carbon-rich elements, essentially prehistoric teeth, leading down a muscular throat. It likely used these to crush small particles of organic debris or microorganisms from the sea floor. Even the neck was odd, thinner than the rest of the body and capable of bending downward to point the mouth toward the ground. And then there were the spines, 7 pairs of them, long and needle-like, curved gently backward from the creature's dorsal side. These weren't used for movement, but likely served as a brutal defense system, a spine-covered deterrent to any Cambrian predator brave enough to try and swallow it. The spines were anchored by soft tissue swellings, almost like muscle humps, which gave them some structural stability. Even among the surreal life forms of the Cambrian seas, Hallucigenia stood out. It was as if evolution had thrown together a worm, a caterpillar, a sea urchin, and a vacuum cleaner, shaken them in a bag, and dumped out the result. But the question remained: what exactly was it? For decades, no one could agree. It didn't neatly fit into any known group. It wasn't a mollusk, an arthropod, or a true annelid. Eventually, researchers grouped it with the lobopodians, a catch-all term for worm-like animals with stubby limbs called lobopods. These ancient creatures are considered early relatives of arthropods, like insects, spiders, and crustaceans. Hallucigenia, in particular, seemed most closely related to the velvet worms, a rare and ancient group still alive today in tropical forests. But even that classification sparked controversy. You'd think that once scientists figured out which way Hallucigenia walked, things would start making sense. Not quite. Even today, paleontologists are still arguing about what this creature actually was. Hallucigenia is widely grouped with a now extinct set of early animals called lobopodians, worm-like creatures with stubby limbs. These strange animals are thought to be the ancestors or close cousins of modern panarthropods, a massive umbrella group that includes arthropods, insects, spiders, crustaceans, tardigrades, and onychophorans, better known as velvet worms. That's where the debate heats up. Many studies have proposed that Hallucigenia is a stem-on psychophoran, meaning it's an ancient relative of velvet worms. The strongest evidence? Its claws. Detailed studies revealed that Hallucigenia's claws were made from stacked sclerites, tiny, hardened building blocks, which are built in the exact same way as the claws and jaws of modern velvet worms. That's not just a coincidence. That's what scientists call a homologous trait, a sign of shared ancestry. But not everyone agrees. Other researchers argue that those similarities are simply primitive features, traits that go all the way back to a common ancestor of all panarthropods. According to this view, Hallucigenia wasn't a velvet worm relative at all, but instead something even more ancient, a sister group to all modern arthropods. In this scenario, Hallucigenia isn't just a weird cousin. It's a direct glimpse into the evolutionary prototype from which many modern animals evolved. This ongoing debate highlights just how alien and transitional Hallucigenia truly is. It doesn't fit neatly into any box. It exists on the blurred boundary between categories, right at the root of some of the most successful animal lineages on Earth. And just when things couldn't get more surreal, it turns out Hallucigenia might not have been alone. Scientists have since discovered two additional species, Hallucigenia fortis and Hallucigenia hongmaya, both from Cambrian fossil beds in China. Each one slightly different, with variations in head shape, spine size, and leg structure. These discoveries hint at a diverse genus, not a one-off freak, but an entire lineage of otherworldly worms that thrived during one of the most turbulent periods in Earth's history. Despite being tiny and fragile, Hallucigenia survived for millions of years, crawling through the dark, chaotic seas of the Cambrian while avoiding becoming someone else's lunch. It was strange, it was misunderstood, and yet it worked. Somehow, Hallucigenia endured, and in doing so, it left behind one of the most unforgettable fossils of all time, a worm that still challenges everything we think we know about evolution. By all accounts, Hallucigenia should have been an evolutionary failure. It was soft-bodied, barely a few centimeters long, with no eyes to see predators coming, no speed to outrun them, and a brain so rudimentary it likely couldn't even recognize a threat. And yet, it survived. For millions of years, Hallucigenia thrived in the Cambrian oceans, an environment teeming with predators like Anomalocaris, a meter-long apex hunter with serrated claws and a mouthful of crushing plates. So how did Hallucigenia avoid becoming lunch? Scientists now believe its backward-curving spines were its salvation. These weren't just decorative. They likely made it extremely difficult and painful for any predator to bite down. Imagine trying to swallow a cactus, and you'll get the idea. Its low profile along the seafloor also kept it out of sight, and its flexible legs helped it scavenge for dead organic matter without needing to compete for prey. In a world that favored survival of the fiercest, Hallucigenia cheated the system with one of the most absurd designs imaginable. That's the paradox. It should have failed. But evolution doesn't care what makes sense to us. It only cares what works. And somehow, against all odds, Hallucigenia worked. Hallucigenia reminds us that evolution isn't a straight line. It's a chaotic, sprawling experiment filled with dead ends, miracles, and biological hallucinations. So the next time you hear someone say, "That animal shouldn't even exist," remember Hallucigenia. It shouldn't have either, but it did. And in doing so, it rewrote the rules of paleontology, flipped our understanding of evolution upside down, and reminded us just how wonderfully weird our planet's past really was. Until next time, on Our Planet Extinct.